Hi everyone, welcome back. So in the previous video, we have learned about the deployment, rolling update and rollback. And today we are going to learn about the different deployment strategy in the Kubernetes. So in this video, we will learn what is the deployment strategy, and we will also explore four major deployment strategy such as rolling update, recreate, blue, green and canary. And we will also see live in the Kubernetes cluster. So let's get started. So what is a deployment strategy? So deployment strategy is the method that Kubernetes use to update the application from one version to another version. So whenever you make change to the application, such as updating the container image or changing the configuration, a Kubernetes needs a way to replace the old pod to the new pod. And there are four common deployment strategies: rolling update, recreate, blue, green and canary. Now rolling update and recreate are the built-in Kubernetes native deployment strategy, whereas the blue, green and canary are the industry standard deployment strategy. Now let's look each strategy one by one and see how it works. So first we have a rolling update. Now rolling update is the default Kubernetes deployment strategy. So if you don't specify the strategy in the YAML file, Kubernetes automatically use a rolling update. So let's say your application is running with the 4 pods and all are using version v1. So whenever you apply rolling update deployment strategy, Kubernetes first remove one v1 pod and replace with the v2 pods, while other 3 pods are keep running. After the one v2 pod become healthy, Kubernetes remove one v1 pod and recreate another v2 pod. And Kubernetes continue this process and replace another v1 pod with v2. And finally, Kubernetes replace all v1 pods. And during this entire process, load balancer send the traffic only to the healthy pod. And whenever Kubernetes perform the rolling update, it uses two settings to control the process. So first we have a max unavailable, and which define how many pods can be unavailable during this update. Second, we have a max search, and this defines how many extra pod Kubernetes can create above the desired number of replica during this update. Now let's talk about the recreate strategy. So in this strategy, Kubernetes first stop all the existing running pod and create a new pod with the new versions. So let's say application is running with the 4 pods with using version v1. When a new version is deployed, Kubernetes first stop all v1 pods and then start a new v2 pods. And during this time, no pods are running, so application becomes unavailable and user experience a downtime. And after this upgrade, application is again available and ready to serve the traffic with v2 pods. And the key point is, it is simple and easy to implement, no need to run the old pod and new pod together. And the biggest disadvantage is the downtime during the deployment, and it is not suitable for the application that require high availability. Now let's talk about the blue-green deployment. A blue-green deployment uses two environments. First is blue, which is current version, and the second is green, which is new versions. Both versions run at the same time, and once the new version is tested, traffic is switched from blue to green by updating the service selector labels. So let's say application is running with v1 pods, that is blue environment, and serving the traffic. So at the same time, Kubernetes create a v2 pods which is ready but not serving the traffic, and the both versions are running side by side. So you can test and verify the v2 pods before sending any traffic to them. So once v2 is verified, load balancer switch the traffic from v1 to v2. So blue-green deployment provide a zero downtime by switching the traffic to the new versions only when it is ready, but it costs more because both versions running at the same time. Now let's talk about the canary deployment. A canary deployment is the deployment strategy where a new version is released to a small percentage of user while most users continue to use older version. So in the step 1, we deploy one v2 pod alongside with the existing v1 pod, and only a small percentage of users such as 10% are routed to v2 for testing, while most users continue using v1. And if everything working as expected, we increase the number of v2 pod and send more traffic to the new version. And at this stage, traffic may split 50-50 between the v1 and v2. And once we are confident about the v2 pods, we replace all the v1 pods with v2 pods. And now 100% of users are using the new versions. So canary deployment reduces the deployment risk by gradually releasing a new versions to the small group of users first, but it's more complex to configure and manage. Now let's see all the strategy on the real Kubernetes cluster. And for this, we will open the killercoder.com. We will select the playground, and then we will select the Kubernetes cluster. Now let's check the cluster status, and our cluster is ready. Now let's see the first demo rolling update. So first we will create a YAML file, and we will press -i and paste the YAML file. So in this YAML file, we have mentioned type is equal to rolling update, and we have also two parameters, max unavailable and max search. Max unavailable means how many pods can be unavailable during this update, and max search is equal to how many pods can be created above the desired state. So let's save and exit, and let's create the YAML file and check the status. So we have created the YAML file, Now let's check the status. Now the status is running. Now let's trigger the rolling update by changing the image from Nginx 1.25 to Nginx 2.6. And let's watch the rollout status. And you see the running pods are terminated one by one and new pods are getting started one by one. And the application never goes fully down at any point of time during this process. Now let's do the cleanup. And let's see the second demo for the recreate. So we will create a YAML file and we will press -i for the insert mode and we'll paste this YAML file. So in this YAML file, if you see, we have mentions type is equal to recreate. Save and exit. And let's create the deployment file and get the status. So pods is running now. Now let's trigger the update and watch the status. And you see all the running pods are terminated at the same time, and this is a small moment where no pods are running and you see the gap, and the gap you see is the downtime window. Now let's do the cleanup. Now let's see the demo for the blue green. So in this demo we have a 3 YAML file. First is the blue, then we have a green, and then we have a service. So let's see everything in action. So first we will create a blue YAML file. We will just copy this, colon wk and save and exit. Then we will create a green YAML file and we will copy this YAML file and paste it here. And then we will create a service YAML file. We will save and exit. So let's try to run the YAML file for the blue and service first. Let's try to list the service, and you see we have a my app as a service. Now let's try to grab the IP address and do the curl request. And you will see the output is equal to blue versions. And now let's deploy the green versions. And let's see the deployment if it is ready. So our both deployment is ready. Now let's try to switch the traffic from blue to green. So in this service YAML file, if you see here, we have defined app is equal to my app and the version is equal to blue. And we will change from blue to green here. And we will try to give the same curl request. And you see output is green versions. Now this demo has completed. Now let's do the cleanup. Now let's see the next demo, that is Canary deployment. In this demo, we will have a 3 YAML file. First is a stable, then we have a Canary, and then we have service. Let's try to run the file first and then we will understand. Now create the Canary YAML file and press -i and paste the YAML file. Then let's create the service YAML file and we will paste the service YAML file here. Now let's execute all the file which we have created. Now let's get the status. All of the pod are running. Now let's check the service. Now we have a 10 pods, so 9 stable and 1 Canary, and roughly 10% of traffic goes to the Canary. So we will replace this IP address in this loop and we will run this. And the most response will show the stable version v1, and occasionally you will see Canary version v2, and this confirm 10% of traffic is going to Canary and remaining is going to stable versions. Now let's gradually increase the traffic and make 50-50. So we are going to scale the deployment and let's run the for loop again. And you see we are getting the response from the both pod. Now let's promote the full rollout and run the loop again. And you see we are getting the request only from the v2. So you might be wondering, how does Kubernetes decide whether the request go to stable version or Canary versions? So let's understand. So our service is configured with the following selector, that is app is equal to my app, and this means Kubernetes look for the all pods that have label app is equal to my app. So in our example, both stable and Canary pod have this label, so they are automatically added as an endpoint of the service. So you can verify by running this. Now, whenever a request sent to the service IP, Kubernetes load balance the traffic and send across all matching endpoints. Now let's do the cleanup. So let's quickly recap what we have learned today. So rolling update is the default deployment strategy. It replaces the pod gradually one by one so application always stay available. And it is best for the most suitable application. A recreate stop all the running pods first and then restart a new pod with a small downtime. A blue-green runs two environments at the same time and switches the traffic instantly by updating the service selector. A canary sends a small percentage of traffic to the new version first and you gradually increase as confidence grows. And here we have a few comments that can be used for different deployment strategy. So that's everything about the Kubernetes deployment strategy. In the next video, we will learn about the daemon set. If you have any question, feel free to ask in the comment below. Thanks for watching and I will see you next video.